Welcome to all. In the earlier video, we had discussed about the synthesis of synthetic petrol by three methods. First one is by polymerization, second one is by Fischer-Tropsch synthesis, and third one is by Burgess method. In this method, we will discuss about refining and reforming of gasoline. So now first coming to the characteristics of gasoline. An ideal gasoline must be cheap and readily available. It must burn clean and produce no corrosion on combustion. Should mix readily with air and afford uniform manifold distribution. Uniform manifold distribution means it should vaporize easily. It must be knock resistant. Ideal gasoline should not ignite easily. It should not tend to decrease the volumetric efficiency of the engine, and it must have high calorific value. So these are the some of the characteristics of an ideal gasoline. So coming to gasoline. The straight chain gasoline contains mainly undesirable unsaturated straight chain hydrocarbons and sulfur compounds. The former gets oxidized and polymerized, thereby causing gun and sludge formation on storing. Sulfur compounds lead to corrosion of internal combustion engine. We will discuss in detail about internal combustion engine in the coming videos. Coming to the refining of gasoline. Refining of straight line petrol is done as follows: by removal of impurities, by reforming, addition of inhibitors and blending. So coming to the removal of impurities. Straight line gasoline mainly contains sulfur as an impurity. So the impurity sulfur can be removed by adding sodium plumbite to sulfur compounds. This on slow addition of sulfur forms lead sulfide. So this entire process can be called as sweetening process. So this process is called as sweetening process. So here sulfur impurities means, so these are the mercaptans. So these mercaptans, which are existing as impurities in straight line gasoline, react with sodium plumbite so this will give rise to sodium hydroxide plus lead mercaptide. This one is called as lead mercaptide. This is already we know sodium hydroxide. So this lead mercaptide will react with sulfur and forms lead sulfide and disulfide compound. This lead sulfide can be removed by filtration and this disulfide can be removed by extracting into suitable solvent. So in this way we can remove the impurities. Next one is reforming. The main objective of reforming is to improve the anti-knocking character of gasoline. We will learn in detail about this reforming process in the next video. Now coming to the addition of inhibitors. Here the straight line gasoline will be mixed with inhibitors like aromatic phenols and aromatic amines to retard the oxidation reactions. Thereby we can improve the quality of storing. Next one is blending. Here the refined gasoline may not have good combustion characteristics. The combustion characteristics of the gasoline can be improved by blending with high octane number fractions. So high octane number fractions are blended to gasoline so that we can achieve the required characteristics, that means combustion characteristics. Now coming to the reforming. It is a process of bringing structural modification in gasoline with the primary objective of improving anti-knocking characteristics. Here reforming can be done in two ways. One is by thermal cracking, second one is by catalytic cracking. Now coming to the thermal cracking. Coming to the thermal reforming. So in thermal reforming, the reforming process is carried in absence of catalyst. So here the feed means nothing but the straight run gasoline. This will be heated to a temperature of 500 to 600 degrees centigrade at 85 atmospheric pressure. After that the gasoline is quenched. Here the quenching process is carried to control the conditions of the reaction. So here quenching is achieved by spraying cold oil. Here the cold oil will cool the products. As a result, gases formation can be reduced. After that the mixture will be fractionated. Here in thermal reforming, some catalytic cracking process, some cracked products also results. Some cracked products are also formed in thermal reforming. mainly alkenes and alkanes will be formed. Here the alkanes will undergo dehydrogenation followed by cyclization leading to naphthalenes. That means aromatization takes place. And here alkenes may be isomerized to N-alkenes. N-alkenes may be isomerized to cycloalkenes or branched alkenes. Mainly branched alkenes will be formed. After that, the gasoline will be stabilized here so that the undesired gases will be removed, and finally we will be getting the reformed gasoline. Next method is catalytic reforming. Here the reforming process is carried in presence of a catalyst, and the commonly used catalysts are platinum supported on alumina. Here the feed gasoline, that means the straight line gasoline, is preheated and next it is fractionated to remove low boiling components. Along with that, water and oxygen will also be removed so that we can avoid the explosion reaction with hydrogen. After that, the mixture will be compressed with hydrogen gas, and here it will be heated to 500 degrees centigrade. Here the mixture which is heated means the mixture which contain the boiling point of 100 to 190 degrees centigrade. Why means the fractions which have, the components which have below 100 degrees centigrade will be preheated and fractionated here only. After that, the mixture which is heated to 500 degrees centigrade and compressed with hydrogen gas, after that it will be compressed to 25 atmospheric pressure in a compressor. After that, the mixture will be passed into a series of catalytic beds. So already I told you here the catalyst is nothing but the platinum supported on alumina. Here the mixture before passing from one catalytic bed to the other catalytic bed, it will be heated. Why means the reforming process is endothermic. That's why before passing from one catalytic bed to the other catalytic bed, the mixture should be heated. After that, the gasoline will be treated to remove H2 and H2S. H2S can be removed by treating with diethylamine in H2S scrubber, and coming to H2, some amount of H2 is recycled to remove sulfur impurities, and remaining amount is used for hydrogenation. after that the products which are coming from the condenser, that means from here, will be passed into the fractionating column. Here the undesired gases and high boiling fractions will be removed. So finally here we will be getting the reformed gasoline. The main difference between thermal cracking and thermal reforming and catalytic reforming is that in thermal reforming catalyst will not be used, and in catalytic reforming catalyst will be used. So now coming to the main reactions during catalytic reforming. So first one is dehydrogenation. In dehydrogenation reaction, what are the most common dehydrogenation reactions that may take place here during catalytic reforming is cyclohexane. This will undergo dehydrogenation forming benzene. Next one is dehydrocyclization, hydrocracking, isomerization. So dehydrocyclization, coming to dehydrocyclization, 3, 4, 5, 6, 7. N-heptane, this will undergo dehydrocyclization and forms methyl cyclohexane, which will further undergo dehydrogenation. 3 molecules of hydrogen will be removed and forms toluene. Hydrocracking. For example, if we take N-decane, this undergoes hydrocracking, means reacts with hydrogen and forms N-heptane. Sorry, hydrocracking, no, 2 molecules of N-pentane. And now coming to the isomerization. Here N-hexane, it may be isomerized to CH3, CH, CH3, CH2, CH2, CH3. That means 2-methyl pentane. So these are the main reactions that may occur during catalytic reforming. In the next video, we will discuss about internal combustion engine. Thank you.